Hello everyone. Welcome back to Kredict. This is 45-day Learn Blockchain Development Challenge with Kredict. In this challenge, you are going to learn blockchain development from scratch. Today is day 21st of this challenge, and in previous videos we have covered nearly all the important topics in Solidity, and in today's video we are going to create our own first crypto token using Solidity. Yes, token is generally a software program written with Solidity or similar language which can be represented as an asset on blockchain. For today, we are going to develop a similar kind of token and we generally follow the ERC20 standard for this. What is exactly? We will cover this in later video, but for today we are going to see practical hands-on experience on how to create your own crypto token with Solidity. So for this, I'm just gonna quickly open my browser. Chrome, in my case, you can use whatever you want. And if you remember, we have this blockchain tutor folder in which we have all the smart contracts we have written so far. So in this folder, I'm gonna create a new folder. What we can say projects. So now, if we have covered all the topics, now we are going to create some projects in Solidity. So this is folder for that. Okay. So in this, just create a new file. I'm gonna name it as you can say my token. You can name whatever you want. Token.sol. So this is the file in which we are going to write our source code, or you can see smart contract for our token. So just quickly start with this boilerplate, and I want to use version 0.8.20, and my remix ID will automatically configure it for me, or if I want, I can manually go to 0.8.20 because this is a cap here, which means this will work on 0.8.20 and all the latest versions. So this will keep it on 0.8.24, but if you want, you can change it manually here. Okay, so without wasting any much more time, just let's quickly start writing our code. So I hope you know all about like data types, variables, mappings, structures, and all these stuffs and features in Solidity. If you don't know what we are talking about, just go watch the video from first, and you came to know each and every topic in very detail. Okay, so just I'm gonna write my contract. So I'm gonna name it as contract, and just for simplicity, I'm gonna name it as my token. So this is my contract is created. I have my basic structure, and in this scope, from line number 5, we are going to write our actual code. So generally, what a token consists, a token has a name, symbol, decimals, and total supply in general. We are going to see a very basic example, and always make sure this is not a production ready. We are just seeing how we can create a basic token and how the actual token logic work. Okay, so just write here string, and this is a public because we want getter function for it. We want to people fetch our token name from the address, and I'm going to name it as name. Second thing is it has a symbol, public. It's also public, and I'm going to name it as symbol. And to follow the basic ERC20 standard, we have to keep all these names as we are using here. So it's always be name and symbol. What exactly this? If you have seen any token, for example, you can see Bitcoin is a cryptocurrency, but I'm taking example like Bitcoin is the name and BTC is the symbol. And if you talk about the credit token, the credit is the token and the KDT is the symbol for it. So this is what we are declaring here. Okay, so now in next line we are going to create a uint 8. Yes, the standard for decimals is always the uint 8 because this is a 8-bit unsigned integer, and name it as decimals. And fourth important variable we are going to create is just close this thing. This automatically pops up each the library we are creating, and it's creating the syntax tree for it. Okay, so just write here uint 256 and public, and name it as total supply. Make sure to name it as it is. I am writing here total with small and supply with capital S without any underscore. So now this is our basic variables configured. Now we have to keep track of balances for each the user. So I'm going to create a mapping here, and I'm going to do it as address. Okay, so this will store unsigned integer 256 bit and public, and name this at balance off. This is the convention, so we have to write just balance off. And then okay, so we are just going to keep track of balance only in this token. Okay, so now we have to create some events here. So I'm going to create an event transfer. This event is triggered when someone transfer the token amount. So this will be write indexed. If you're confused with index, don't worry, we will cover this soon. And second is address indexed, you can say 2. And the third is unsigned 256 is value. So for now we only require one event. Okay, so now this time for constructor. So what we're going to create, we are going to create a constructor, and for now we are going to create a owner for our token that holds all the balance initially. So I'm going to do it as owner. Okay, so this is it. Now create the constructor, and what will is take, this will gonna take string memory name, just write it as underscore name. Second thing, it will take string memory its symbol, because we are going to take this value from the constructor itself, or to pass to constructor itself, what we can say. Second thing is unsigned int, we want the decimal, so write decimals. Second thing is the total supply, so 256 and the initial, or you can say total supply. So generally we write initial supply, but this will initialize to total supply at later. Okay, so just close this to have a clear view. Okay, so now constructor is ready. Just open the body of constructor and initialize all the values to the respective things. Okay, so the name, second thing is symbol, underscore symbol. The third is, I think, decimals, you can say. So assign the decimals. And now to get the total supply, because we are taking this value as the actual integer, but we are going to convert into v, the smallest unit, according to a decimal. So it is like total supply equal to initial supply multiply by 10 to the power, you can say, typecast it to unsigned int, and just write decimals here, because this is unsigned 8 and this is unsigned 256. So that's why we have typecasted it to have a clear and concise calculation. Okay, so now initially we assign the total balance to the first owner and the owner of the token. So we are going to map this as balance of, you can say, message.sender, because the person who deploys this contract is automatically assigned as the owner. So you can say total supply to that, and just mark the owner as the owner equal to message.sender. Or you can do this the vice versa, first assign the owner and then the total supply. And actually this is just a number. If you have some token, this does not mean you have physically something. This is like the token contract has a field where your address has some values. So the token balance is actually this thing. For example, let me clear this thing to you. If you have a crypto wallet and it shows some token and balances, that this does not mean that these values are stored in your wallet. The wallet is just a way of representing something. A wallet actually does not hold anything. The physical wallet, what you can say, I mean the physical, not the software based wallet like MetaMask Trust Wallet. They does not hold anything. They just represent and provide you a interface to deal with your balances and all these tokens. So but we have learned here that the balance is just a number, like you can say in your bank account, which gets updated on each transfer from you to another, from another to you. This is just a number game, and it's all things stored in the token smart contract itself. Okay, so basic concept. Now we are going to emit the first transfer here, because we have transferred some amount to owner, so we are going to emit, but we can say transfer here. And from, we can say address 0. This is like null address. This is generally the convention for first initialization, and what you can say message dot sender, and value is the total supply. Okay, so now our constructor is ready. Now we just require a single function to transfer from one to another address. Actually, the original token has many functions, but for now we are just going to write a transfer function here. To follow the convention, just name it as transfer. And what the problem here is, this is not R, this is function. Okay, so now what this value take? This will take the address A double D R E double S, but you can say 2, and we have to take the value. So I'm gonna pass here like value. This is a public function and it returns the status of success or not. So we are going to write it as bool because we are going to return the success message. Okay, so I think we have now. Okay, so just open the transfer body. First we check the balance, and before that we will check the address is not 0 because we can't send to a invalid address. So you can say invalid recipient address. Okay, so we have checked this. Now second thing is we'll check for balance of, we'll check the balance of message sender because he is sending the some amount, so we will check balance for it. So it must be greater than or equal to the value uh, he or she want to send, so it's always should be greater than value. And what the error message here is insufficient balance. I'm just following the basic convention. You can write according to you, but it's always better to follow the convention. So balance of, we just decrease it from the, what you can say, the sender minus equal to value, and update the balance of in which address we are sending. So here you can see we are just updating the values. There is nothing actually transferring from someone to some other one. We just updating the values. So why is this error? Okay, so just write this value. Okay, sorry, this is the message dot sender. Okay, so now what left? We have to emit the transfer function here. I mean transfer event here, sends from message dot sender and underscore 2, and just keep this as underscore value. Okay, so I think our transfer function is complete. So we need to return, if everything is success, we just return true. Okay, we just return true. So I think the function is completed. Okay, so I think our basic token function, our contract is ready. So just quickly gonna deploy this and test the implementation. Okay, so I'm gonna deploy it on basic virtual machine. We will see in future video how we can deploy this on you can say the real net or test net, but not the virtual machine. Like we have in first video we have seen the Sepolia test net, but we haven't used till now. So we will going to use that very soon. For now, just going to deploy it on virtual machine. Okay, so just select your smart contract, make sure the contract is compiled, or if you are not sure, just click on compile my token, and it should resemble the name of your file here, my token. I just keep the convention of writing contract and file name same. You can follow this if you like, but there's no problem at all. But this is a good practice. Okay, so just okay. So here you have deploy. We have to, what we are going to say it. We are going to say just like my token, and it's like myt my token, and decimal. You can always put decimal from like under 18. For example, you have to maximum 18, but we are just going to write here, you can say 16 decimal places, just like this. These have a proper calculation how and what decimal place you actually have to choose, but for now I'm just gonna type 16 as straight. Okay, and the initial supply I just want to have what you can say 50,000, you can say. So this is 50 and 30, so it's 50,000. Yeah, this is very small, but what we are going to do this with dummy token, so just keep this as it is. So click on transact, and our contract is deployed successfully. If you scroll down, you can see we have basic token smart contract. If you check the name, our token name is my token. Owner is, yeah, the default address we have set here. This is symbol is MYT, total supply is this. And now you are seeing this is a lot of numbers, but actually this is in real the 50,000, but it has 16 zeros in past. For example, it's okay. So I think this is 50,000 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think this is less zero. Why this is not 16? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, yes, there are 16 zeros. Huh, my bad. So now we are going to check the balance for our, because we are the owner now, we can see. So we must have this whole amount in total. So if we call, you can see the same amount as the total balance because we are initial owners and initially we have all the tokens. Now we are going to transfer some to my friend. For example, I want to send this to this address. Just copy, paste the address of receiver and the amount. So because we are using remix, we have to type the values in actual v format. So just copy this, paste, and I'm going to just pass the half of it. So I'm just going to write 2 and 5. So I'm going to send the half amount. So I'm going to transact what is insufficient. Oh, sorry, I have to remove the 1 0. Okay, so just click on transact. What is this the problem here? I've changed the address. Just make sure to put your address back and put the 0 because this is the real thing. Just click on transact, and now you can see the contract function successfully executed, and you can see the event transfer has emitted and the amount and all this stuff. So now if we check our address, you can see now we only have half of the amount. And if we check address of my friend and call, you can see this is the same amount. Okay, I think this function is not evaluate this as paste again and call. Okay, so now this is same. To make this clear, just now get to second address, copy third address and get to second address, and now transfer some value from second address to third address. Okay, so I'm gonna just random number to see the clear difference. Just like this is a random number, but you can type here. Click on transact, and now if you check the second address balance, you can see this is something changed, and the third, okay, just call, and you can see this is the same number. So now we can say that our transfer function is working perfectly, and we have created our first token, the most basic token you can create ever. So congratulations, we have come a long way in this Solidity journey, and now you know how this thing are created. And if we are think why we have this function says balance of, because we have not created any function like that. So I'm gonna make this thing clear to you because we have written public here. And if you don't know, just go to see the I think keywords video in this series, in which we have described how to get a automatically getter function from a variable. Just put the public there and it will create, the Solidity will automatically create a getter function for this. So because we have a balance which takes address, because it's a map, hash map, which have key values pair and every key should be unique. So address is like key, and it automatically gives a field where you have to put address and it will return the unsigned integer, which is the balance. So this is just a trick or the feature of Solidity. You can type public here, and if you don't want to type public here, just remove the public here and create a manual function like balance of, and do the same stuff. You know how to do this. If you don't know, just go and watch previous videos. And this is highly recommend to watch all the videos in the series to get the exact point what we are doing and what we are going to do in future sessions. So this is how you can create a basic smart contract of a crypto token, or you can EVM-based token. And generally, we tends to follow the ERC20 standard because this is the most common standard in tokens in EVM chain. And we will see how to extend this contract for further features, like you have allowance, you have transfer from. Transfer from is a function in which instead of sending me to you directly, someone else can send tokens from my wallet to you, but I have to allow him some. So what this thing, just don't worry if you don't understand for now. We will see this in next video, or you can say in future videos. Then we will cover all these topics. Okay, so I hope you may now know how to do and create a smart contract by your own for a crypto token. So this is all for today. This is 21st day, and I will see you in next day of this series. Till then, stay safe.